Hello, Algebra 2 students. We are learning a new topic today called polynomial long division. I think it's worth noting that you guys have already added polynomials together and subtracted polynomials and multiplied polynomials, but something you haven't studied yet is to divide polynomials. And there are actually going to be two different types of polynomial division that we're going to study. Today's lecture is on long division, and the next lecture, 5.5 Part B, is going to be on synthetic division. Now, both of these methods of division of polynomials are going to be useful for us. You're going to need to know both on the Chapter 5 test. And we're starting with long division. Long division is the longer of the two processes, hence the name. It's the more complicated of the two, but it works for every polynomial division problem. Synthetic division only works in unique circumstances. So that's why we need both. In order to be good at polynomial long division, you are going to need to know how to do regular long division. And so this is kind of a blast from the elementary school past. You guys probably haven't done this in years. So let's see if we remember how to divide these numbers together. So if you remember, the answer is going to go up here. And the answer to a division problem is called a quotient. And this is called the divisor. It's what we're dividing by. So for this problem, how you would answer this is you would first say, hey, how many times does 18 go into 4? And if you're with me today, you'd be like, well, 18 doesn't go into 4. So then you move on to the next digit. You'd say, how many times does 18 go into 48? 18 actually goes into 48 two times, 2 and some change, right? A little bit more than 2. So you round down, you say, okay, 18 goes into 48 two times. And anytime you write a new number up here, you're going to multiply it by your divisor. So you're going to do 2 times 18. 2 times 18 is actually 36. And then from here, hopefully this is kind of, jogging your memory. You do 48 minus 36, and you would get 12. And the very fun part of long division, you drop the next number down, and you get 121. That is going to be one revolution of the process that you're going to use to answer this question. And you're going to kind of keep repeating this process until you finish the problem. So your next step is to say, hey, how many times does 18 go into 121? Remember, last time we said how many times does 18 go into 48? Now we're just going to move down here and say how many times does 18 go into 121? 18 goes into 121 6 times. So the next answer to the next part of our answer, our quotient, is going to be 6. Our next step is to do 6 times 18. 6 times 18 is 108. And just like we did here, we did 48, we did 2 times 18 and got 36. Now we do 6 times 18 and get 108. We then subtracted them. That's what we're going to do here. 121 minus 108 is 13. After you do the subtraction, drop the next number down and start over. Another revolution, another cycle of this process. We did how many times does 18 go into 48? Then how many times does 18 go into 121? Now, how many times does 18 go into 135? And 18 goes into 135 7 times. Then you would take 7 times 18, and 7 times 18 is 126. Once again, subtract those, and you would get 9. When you first started learning this, you were probably told that 9 is your remainder. And how you indicated that was you wrote R9 here. Now, eventually, you took a step up in your understanding of math, and we don't really talk about remainders very often. We talk about fractions and decimals a lot. So how we would convert this is we would say it's 267, and whatever your remainder is, over your divisor. So over 18. So the remainder went here, and the divisor here. We would, of course, reduce that fraction, and so our answer is really 267.5, or 0.5, one of the two. And yeah, that is long division. You could verify this with your calculator if you wanted to. Unfortunately, we can't easily verify polynomial long division with our calculator, and hence the reason we need to know this process. Let's take a look at our first example. The thing we are dividing by is x minus 2. That's going to go out in front. Division symbol, and this whole polynomial is going to go underneath the division symbol. X to the third plus 5x squared minus 7x plus 2. I want to reiterate that the process for this is going to be the same as regular long division. Before we ask the question, how many times does 18 go into 48? Now we're going to ask, essentially, how many times does x go into x cubed? I like to ask that question that means the same thing in a slightly different way. How I ask that question is what, and this is going to be part of your product, or part of your quotient, part of your answer, what times x is x to the third? Hopefully, if you're thinking what times x would you get x to the third, you would say x squared. And I'm actually going to write that right above the x squared here. That helps kind of with aligning everything. So I get x squared. And now what you do, just like when you wrote a new number up here, you multiply that by everything out here and write it here and here. So you're going to do x squared times x. That gives you x to the third. You're going to notice it matches. It always should. The first term should always match. And then you're going to do x squared times -2, and x squared times -2 is -2x squared. From here, you're going to subtract x to the third, right? That's what we did back here as well. So I just want to remind you guys. Right here, we did 48 minus 36 and got 121, or 12. Here, we're going to do x cubed minus x cubed. They cancel. They always should. And the next part is to subtract 5x squared minus -2x squared. This is going to be a super common spot for a mistake. Lots of students are going to write 3x squared here, but remember, you are subtracting all of the time. So 5x squared minus a -2x squared is actually 7x squared. Right? Remember, minus a negative turns into plus. After you do the subtraction, just like we did with the regular long division, you're going to drop the next term down. That right there was one cycle of this. Let's do it again. So how we started this was we said what. We didn't have this x squared here. We said what times x is x cubed. Now we're going to say what times x is 7x squared. And hopefully if you're thinking what times x is 7x squared, you would come up with 7x. Once you pick a new number here, you're going to multiply it by everything on the outside. 7x times x would be 7x squared. I told you it should match, and it does. And 7x times -2 would be minus 14x. From here, you're going to subtract. These should cancel because they always match. And then keep in mind, tons of mistakes are going to be made here. -7x minus a -14x is positive 7x. After you do the subtraction, drop the next one down, +2. That was another revolution of this process. We need to do it again. We need to do it until there is no number to drop. So now we ask the question, what do you multiply x by to get 7x? And that's just a plain 7. Notice we're kind of always aligning these up with each other. The x squareds match, the x's match, and the things without x's match. Now you do 7 times x and you get 7x. That matches, yay, yay. 7 times -2 is minus 14. Subtract them, they cancel. And then we have a 2 minus a -14. That is positive 16. At this point, you would look to drop the next number down, but there's nothing to drop. That tells you that this is going to be the remainder. And what we are going to do with that remainder is we are always just going to write plus, and there isn't always going to be a remainder, but when there is, you're going to write plus, and then whatever that remainder is, which is 16, that's going to be your numerator, and x minus 2 is going to be your denominator. So our final answer is x squared plus 7x plus 7 plus 16 over x minus 2. I told you this wasn't going to be a super easy process. This is a lot of potential for mistakes. Take it slow. Let's do one more together, and then I'm going to encourage you guys to pause it and try one on your own, see how you do. Our divisor, x squared plus 2x minus 1. That will go there. And this part here is going to go underneath the division symbol. So we'd have 2x to the fourth plus x to the third. However, you're going to notice that the x squared is missing here. There is no x squared listed. You can't just write it like this or you'll have the wrong answer. You need to put plus 0x squared in as a placeholder. If you don't do that, you're going to have the wrong answer. So that will need to happen if you're out here or if you're underneath the division symbol and you skip a term like we did with the x squared term here. So you have plus x minus 1, and this is the setup. First step is to say, what would you multiply x squared by to get 2x to the fourth? And hopefully you guys are agreeing with me that the thing that you would multiply x squared by to get 2x to the fourth would be 2x squared. Once you pick a new number up here, you always multiply it by everything in the divisor. So do 2x squared times x squared, that's 2x to the fourth, they match, good deal. Then do 2x squared times 2x, that would be 4x to the third. And then do 2x squared times negative 1, that would be negative 2x squared. You are going to subtract these, being very careful to not make any mistakes. 2x to the fourth minus 2x to the fourth cancels. X cubed minus 4x cubed would be negative 3x to the third. And 0x squared minus a negative 2x would be positive 2x squared. And always after you do the subtraction, drop the next term down plus x. That is one revolution of the process, and we get to do it again. The first question you start out with is, what do you multiply x squared by to get negative 3x to the third? Hopefully you guys are agreeing that that would be negative 3x, because negative 3 times 1 would be the negative 3, and the x times x squared would be the negative x, 3x cubed. Negative 3x times 2x would be negative 6x squared, and negative 3x times negative 1 would be positive 3x. We're going to go ahead and subtract these. These match, so they cancel. 2x squared minus negative 6x squared would be 8x squared, and x minus 3x would be negative 2x. Drop the next term down, minus 1. Now we do it again, right? Another revolution of the same process. So we'd have to ask ourselves, what times x squared is 8x squared? And that would be an 8. Multiply 8 by all three of those, you would get 8x squared plus 16x minus 8. From here, you would subtract these. These cancel. Negative 2x minus 16x would be negative 18x. Negative 1 minus negative 8 would be negative 1 plus 8, which would be positive 7. I would look to drop the next term down, but there isn't a next term, which is to tell you that this is the remainder. And how we use that remainder is we write plus a negative 18x plus 7 over our divisor, x squared plus 2x minus 1, final answer. Like I said, I think this would be a great opportunity for you guys to try your first polynomial long division problem. Let's go ahead and set it up together and then pause it and make sure that you guys know what you're doing. 3x to the fourth minus 5x to the third. You're going to notice that once again we're missing a term, so make sure you put in plus 0x squared as a placeholder. And this is going to be our problem. First step, remember, is to say what times x squared is 3x to the fourth, and that's 3x squared. I'm going to write it above the x squared. Next step is going to be to multiply 3x squared by all three of these things. I would go ahead and pause it now. Try to do the whole problem and see how you do. Then we'll go over it together. So from here, you do 3x squared times all three of these. You'd get 3x to the fourth minus 9x to the third plus 15x squared. Those are the things that you subtract, right? We got those from doing this times all three. You're going to subtract those. The first ones cancel. Negative 5x to the third minus negative 9x to the third would be 4x to the third. And subtracting those, you'd get negative 15x squared, and then you drop the next one down. That is a revolution, and we get to do it again. What times x squared is 4x to the third? That would be positive 4x, and you're going to multiply 4x by all three of those. 4x to the third minus 12x squared plus 20x. Subtract them. Cancels. Negative 15x squared minus a negative 12x squared would be negative 3x squared minus 16x. Drop the next one down, minus 6. That was another revolution. Let's do it one more time, and I think we'll be done. What do we multiply x squared by to get negative 3x squared? That would be a negative 3. Multiply negative 3 by all three of them. Negative 3x squared plus 9x minus 15. Go ahead and add these. Or sorry, subtract them. These cancel. This would be negative 25x, and negative 6 minus negative 15 would be positive 9. There's nothing to drop, so that's going to be your remainder. So it would be plus negative 25, negative 25x plus 9 over x squared minus 3x plus 5, final answer. Please let me know if you guys have any questions. I'd love to help you understand polynomial long division.